a banshee cry of wind. The thump, rattle, and squeal of metal. Susan Solomon's eyes flew open. It was 1986, the middle of the night, in Antarctica.
There's a crazy windstorm going on and the building is shaking.
And Susan realized, I have to go out there immediately.
Oh my goodness, I gotta get that stuff back down from off the roof.
On the roof, the frozen, wind-torn, shaking Antarctic roof, sat a fragile, expensive, government-owned scientific instrument.
I left it up there thinking, the clouds might go away. I'm gonna be able to take some more data.
If the wind ripped the equipment off the roof, I don't know if it would have been fireable, but it might have been existential. Susan was on this polar expedition trying to solve a global mystery. She's an atmospheric scientist, and she was investigating what was carving a hole in the ozone layer. If you have skin, you need the ozone layer. Her equipment on the roof might hold the key to what was causing the hole, so Susan needed that equipment. She opened the door to the howling wind and started to climb.
I really felt like I was going to get blown off the roof.
This is Are We Doomed? From Nuanced Tales and distributed by the NPR network. I'm Ben Bradford. I have this memory from being in school in the 90s, a worksheet about the ozone layer and a big dark hole punched through it. My teacher's genuine concern. If you lived through it, it was this enormous, terrifying thing, a wound in the sky, yawning wider every year, letting in radiation that could blind you, burn you, give you cancer. And then, at some point, it felt like news about it faded away. I stopped thinking about it. I didn't know why. Now I know why. Because we solved it. Or, with Susan's help, we stopped making the problem worse, put it on a path to heal. And with Susan's help, we're going back to explore why. In this giant international environmental disaster no one could see, the world came together. It's a messy story of false starts, exploding refrigerators, and so much hairspray. But what went right? Why on this problem? And what can we steal now from the story of how humans created a world-changing mess and then actually cleaned it up? Today, the ozone. I'm so excited to talk with you.
I'm excited to talk with you.
I have such memories of the ozone layer of when I was in a classroom.
It was everywhere. I even, would have conversations with people in the grocery store, my neighbors, person sitting next to me on the airplane. They all knew about the ozone hole.
Susan Solomon of precarious Antarctic rooftop perching is one of the key figures in the story of saving the ozone layer.
I'm a professor at MIT, and I have been working on ozone depletion since the 1970s.
High up in the stratosphere, above the clouds and the rain and the air you can breathe, floats a molecule. 3 parts oxygen. That's it. Loosely spread around the world, these little molecules have one extremely useful purpose.
It's essential to protect us from ultraviolet light that would otherwise be very damaging to all biological life on the planet.
The ozone is a thick layer of sunscreen wrapped around the globe, keeping us from frying. Before the ozone layer formed 500 or so million years ago, there was no life on land, and that's probably not a coincidence.
It's absolutely essential to our health.
So that was status quo for about 499,999,900 or so years. And then, prohibition, asbestos, jazz. There were many bad ideas in the 1920s. Radium toothpaste, smoking because your doctor recommended it, and a new consumer appliance. Self-contained home refrigerators that did change lives for the better, but also ran on ammonia and other concerning chemicals.
I mean, you know how toxic ammonia is. If it leaks out of the refrigerator, that's bad news.
We're not talking window cleaner. We're talking thick, concentrated gas that'd blind you or torture your lungs if you got a bad enough whiff.
Yeah, you don't be breathing ammonia.
And tanks constantly leaked or burst. So, our biggest chemical and refrigeration companies, DuPont, GM, Frigidaire, put their top scientists on finding a safer chemical that could do the same thing. In 1930, they unveiled the answer at a trade convention, a new refrigerant called Freon. Generically,
Chlorofluorocarbons, CFCs, chemicals that have carbon and chlorine in them.
neither poisonous nor explodes, touted the Chicago Tribune. Our standards were low. On stage, a score of chemists stuck their faces into a cloud of the new white gas.
Actually inhaled them at an American Chemical Society meeting as a demonstration of how safe these were.
And why doubt its inventor, GM's Thomas Midgley Jr.? After all, just a few years earlier, he solved the plague of engine knock in cars just by adding a little lead to the gasoline. So, CFCs were hailed as another miracle chemical, the safe alternative to ammonia. And in one sense, they were. People stopped dying in refrigerator leaks and explosions. More and more industries found uses for CFCs. Air conditioning, cleaning solutions, styrofoam, fire extinguishers. And above all, very importantly, by the 1970s,
actually 75% of the global use was for stuff that was in spray cans. And the biggest use of spray cans was for personal care products like deodorant and hairspray.
And it was a time when there was a lot of hairspray.
You slept in curlers. Do you have any idea how uncomfortable those were?
I do not. The thing about CFCs is they were safe for our lungs.
As far as the ground level is concerned, they're totally fine.
But if you followed the spritz from a hairspray can and watched how it traveled and where it went, and why would you do that, the story was quite different. What's the first real piece of evidence that these might not be as safe as we thought?
The first indications came from a couple of chemists who were at Irvine.
Go anteaters. Yep, that's the mascot. They found a strange problem. Most chemicals break down where we use them, low in the atmosphere. CFCs weren't doing that. Follow the spritz, and they found it would drift high in the sky.
They get up to the upper atmosphere.
CFCs stay there, floating up to a certain point in the sky.
They find ultraviolet light.
In other words, right where the ozone layer is working.
And boom.
There's a chemical reaction. Chlorine gets released, and that chlorine hunts ozone.
And that would start a catalytic set of reactions. What that means is the chemical that's consumed in the first reaction ends up getting regenerated later.
Chlorine eats ozone, spawns more chlorine, eats more ozone.
Hundreds of thousands of times in its lifetime. So incredibly efficient destroyers of things.
What I'm imagining in my head is just this thing sort of spinning around, eating ozone up in there. Like every little piece of it just spinning around, eating, just Pac-Manning.
Yep, that's a great analogy. That's exactly what they do.
Our UC Irvine anteaters found this reaction. They realized the CFCs released by humans around the globe were traveling up into the ozone and gobbling our crucial natural sunblock. They ran the numbers and almost couldn't believe the alarming forecast it suggested. They'd found
maybe the ozone layer might be depleted by 5 or 10%. And that would happen in a century.
Pretty underwhelming. In 100 years, we were on track to lose a wafer-thin slice of ozone.
So it was a small effect. It was far in the future.
Still, the scientists published their findings, and they went to newspapers. They recommended boycotts of CFCs to protect the ozone layer for generations down the line. Industry pushed back. There was a smear campaign against the scientists, even a rumor one was actually a Russian spy. He was not. They won the Nobel Prize. Manufacturers argued there was no proof of harm. They got their own scientists to stamp that finding. A contrarian movement of CFC denial emerged. A contingent of lawmakers suggested that ozone thinning was natural. So, summon everything you know about how the world works. And what do you think happened next? Scientists had claimed a ubiquitous consumer good, backed by a multi-billion-dollar industry, was wreaking important but invisible environmental destruction that would be a problem sometime in the future. A counter-narrative was casting doubt on it. What happened next?
Lots of people in the United States do a very important thing. They threw away their spray cans.
Susan says the science won out almost from the get-go. Newspapers across the country reported on the problem. The public at large did not buy the counter-narrative, and they responded in massive numbers. Susan remembers the consumer campaign that followed.
You throw away your spray underarm deodorant and you buy the roll-on underarm deodorant.
There were boycotts. Sales of CFC products sagged almost immediately.
They started dropping like a rock.
With sales plummeting and scrutiny rising, just a year after that ozone report, one of the world's largest consumer product companies, SC Johnson, called a press conference. CEO Sam Johnson, in the gripping cadence of a quarterly earnings report, unveiled big news.
We are aggressively reformulating our product ingredients worldwide.
Next to him, a table displayed products with punchy one-word names to protect your furniture, clean your clothes, kill insects, pledge, shout, raid. And the CEO, so excitedly, read a new label on all of them.
Use with confidence. Contains no freon or other fluorocarbons claimed to harm the ozone layer.
This was one of the first to get out of the CFC business. Other companies followed, touting their new spray-free versions.
Get off the can. Get on the stick.
Within 4 years, federal agencies, the EPA, the FDA, the Consumer Product Safety Commission, banned what they called non-essential uses of CFCs, aerosols. The country was indeed
Off the can.
And so, to recap, in the span of 4 years, bombshell report against a miracle substance, public outcry and boycotts, new products, regulation. That flies in the face of everything I know about how the world works now. Why did it work then?
I will say, as a chemist, it wasn't rocket science.
Susan thinks, in part, the initial lift just wasn't that hard. It was pretty easy to choose non-spray items.
The stick.
And to create new spray items without CFCs and slap on a new label.
Let's make the new stuff. That's a growth industry.
Use with confidence.
But that's not the main reason, because it didn't actually solve the real ozone problem. That had yet to even be discovered. This was all the prelude. Important, setting the stage, but prelude. To see what really happened, we have to dig deeper, and we have to go forward in time. Several years later, a paper from Antarctica crossed Susan's desk with a chart that made no sense.
No, this can't be right. Those British people, they don't know what they're doing.
This chart showed, after all the work, the bans and boycotts to prevent wafer-thin damage to our ozone, a gaping hole. A hole that would send Susan to the South Pole herself, to a wind-torn roof. A hole that would require radically different action from anything the world had ever tried. It was the mid-1980s, several years after the bans and boycotts to save the ozone. A different time. Jimmy Carter was long out. Ronald Reagan was firmly in. Deregulation was in, not just here, but abroad. Margaret Thatcher was in the UK. It was boom times and a time to scrap onerous regulations, not add to them. Susan Solomon was a young atmospheric chemist in Colorado, working at the government agency that runs the Weather Service, NOAA. New in her career, and not doing anything related to air pollution. But one day, a new, not yet published report slid into a wooden inbox at her agency.
I was asked to review the paper before it was published.
This was another part of the job, peer reviewing unpublished papers. This one was wacky, from some British researchers in Antarctica. They had a chart.
A long record of ozone.
It was steady for decades.
Everything with little bit of tiny ups and downs, and then boom, 30% of the ozone dropped away in 5 or 7 years.
The report was describing a big divot, like someone had shoveled out a third of the ozone across 8 million square miles. There was a hole in the ozone layer in the Antarctic. Susan remembers the immediate reaction from others who read it.
No, this can't be right. Those British people, they don't know what they're doing.
It seemed ridiculous. Why so big? Why Antarctica? And also, we just solved this.
Get off the can.
Use with confidence.
most of the people in the field, including very, very well-known and tremendous people that I respected enormously, they were incredibly skeptical about it.
But Susan, peer reviewing the report, had to go through the math, the method, the tests.
If they had done everything right, there was no reason not to believe it.
She was pretty shaken by its findings.
I was too young to be closed-minded.
But the reasons for the hole were still unclear. Why Antarctica? What could be causing it? CFCs were not obvious because it's not where they were released. They came from industrial countries, and the damage was way more than they'd ever been thought to do.
And so I actually thought about it a lot.
Her specialty was chemistry of the air.
What's unique about Antarctica? This is not happening in the Arctic, and I checked that too, by the way, of course.
She went to her research office's library.
I decided I was going to find every measurement of ozone that had ever been made by balloons in the Antarctic.
That wasn't in a computer database. The stats she needed were buried in books, lots of books. And you can imagine the montage. A long wooden table, stacks of books piling up, Susan opening one at a time, Susan writing notes, Susan tossing them back in frustration, windows darkening from day to deep night. But mostly, Susan was graphing.
Very carefully, meticulously, I made the graph by hand.
From each book, she copied ozone measurements taken around Antarctica. Each became a dot. Dot by dot, a picture emerged.
I figured out, what altitudes had missing ozone.
She'd drawn the hole. But more, in the pattern, she saw a possible cause.
Somehow I made the connection that it is indeed so cold that clouds can form in the Antarctic stratosphere.
Clouds far above ordinary weather.
I thought about what chemistry could happen on those surfaces.
Without getting into doctorate-level chemistry, suffice to say it's different. And Susan realized how it was different could supercharge chlorine's Pac-Man effect on the ozone, meaning the problem was CFCs. But it was just a theory. She moved from books and graph paper to punch card computer. Sometimes it's good to work for a government research agency. She got access to its $9 million hot tub-sized supercomputer, one of the fastest in existence at the time. She handed the computer's operator punch cards, code for it to model the cold, the clouds, the chemistry, and the CFCs. And she waited in line for her turn, for the machine to model the reaction. A few hours later, the computer spewed paper, results, tables, and numbers showing
I made an ozone hole.
very bad for the world, but great vindication when you're a scientist hand-coding punch cards against the advice of skeptical colleagues.
Yeah, I got pretty excited about it.
Actually, was it bad for the world? If CFCs caused the hole, maybe Susan was seeing delayed damage from chemicals already banned. Even after emissions stop, what's already in the atmosphere can keep working for decades. Could this be a newly discovered problem that had already been fixed? It could not. Because while the consumer sprays, quote-unquote non-essential uses, had been banned, at the same time, other CFC production had quietly skyrocketed. From air conditioners, refrigerators, foam packaging, military uses, cleaning solvents, equipment, woven into more than 200 industries. None of them were.
Off the can.
The nation thought it had handled ozone with the easy move. Get off the spray cans. But the real usage was harder to see and more fundamental. You can throw out your shaving cream, you cannot, as a society, throw out refrigeration. And what Susan had was still just a theory from a computer that couldn't run Windows XP. She wanted hard proof, which led her to Antarctica. In the teeth of winter, to a stormy, travel-restricted area, the National Science Foundation launched an expedition.
16 people, 4 different research groups.
The New York Times described it as a mission to solve a dramatic mystery. 30 years old, Susan was the youngest, the only woman, and the leader. On the roof of a wood cabin, she and her colleagues set up equipment to measure the chemistry of the atmosphere around where the ozone hole had been detected.
Temperatures are minus 40.
It was unpleasant.
My eyelid actually froze at one point.
And of course, one night, wind.
There's a crazy windstorm.
Thump, rattle, squeal.
Oh my goodness, I gotta get that stuff back down from off the roof.
In the dead, dark Antarctic night, Susan, in thick boots, climbed precarious steps.
I really felt like I was gonna get blown off the roof,
She did not. She lived.
which was very exciting.
She came down with the equipment, shut the door to the howling wind. And that was important. She and other researchers picked over the findings from these instruments and others, and they found direct evidence of the hole and the cause, CFCs.
It was the first measurement that actually showed that.
The data was grim. The hole was widening, deepening, threatening to spread beyond Antarctica. What's the trajectory that we're on at that point if we don't curb it? What's going to happen to the ozone? What's life on Earth going to look like?
It's a very scary prospect. By 2030, you've got losses of ozone that are very, very large over the tropics especially. And by mid-century, you've got ozone losses probably starting to approach the Antarctic levels at mid-latitudes.
Skin would crackle from UV burns, eyes would cloud with cataracts, cancer would run rampant with hundreds of millions more cases in the decades ahead.
That would not be a good thing.
We thought we had solved an eventual problem with a relatively easy action.
The stick.
In reality, the problem was far more imminent and massive, the substance causing it never more entrenched.
The can.
So, summon everything you know about how the world works. What do you think happened? Overwhelming support for doing more, for clamping down harder on an invisible, safe-to-breathe, globally useful, although possibly existential, substance. Why? The simplest story you can tell is that all the earlier action in the 1970s had set the table for more. Consumers already distrusted CFCs. They knew how to protest them. Once the hole made news, they did it again.
School kids began to demonstrate in front of McDonald's all around the country to get rid of the styrofoam
Used to package burgers. Resistance was frail. Within months, McDonald's promised to move off CFCs. Within a few years,
actually switched to using cardboard containers.
companies that had previously weathered spray can boycotts could see the writing on the wall for their remaining products.
They needed to get into a different chemical.
Which, of course,
It wasn't rocket science.
DuPont had been developing a replacement that could swap in relatively problem-free.
What's called a hydrofluorocarbon.
HFCs did ultimately have their own environmental problem, namely,
Turned out to be greenhouse gases.
and needed to be subbed out again for another chemical,
Hydrofluoroolefins.
which seems to be better, such as progress. Anyway, it all added up to the largest producer of CFCs also being the nation leading the way to stop using them.
Amazingly, the country that pushed the most was actually the United States of America.
Cities and towns began enacting bans on CFCs. NASA used its tech to confirm and publish visualizations of the problem.
You know, you had these incredible satellite images of the hole in the ozone layer.
A giant dark blue wound across the bottom of the world, splashed in the pages of newspapers and on TV. There were scientists still debating whether CFCs were the problem or whether the hole was natural. That's the nature of research. But no movement of denial gained a meaningful foothold. And so, action spread.
People needed to become concerned about it so that the policy people could actually go and do something. Industry began to realize what the other options were. So industry made different choices.
By 1987, just a year after the trip to Antarctica, 2 years after Susan was plotting the ozone hole on graph paper, diplomats began signing a global freeze on CFC production called the Montreal Protocol. Eventually, every country in the world would sign it.
That makes it the most successful treaty that we have ever produced, bar none.
The nations producing the most CFCs strengthened their commitments over time, from a freeze to new limits to a global ban. Today, the ozone layer is healing. If the recovery stays on track, it should return to pre-damage levels over the coming decades. That's the simple story. And I think it's the one that's usually told.
The whole process worked together.
It's not wrong. There's no question it's a massive success story, perhaps our finest environmental moment as a species. It doesn't really offer a lot of lessons, though. If you want to stop a big, slow-moving global disaster, have the chemistry be easier to solve? Not really a viable answer. But also, that's not the whole story. The lead-up to the treaty was messy. It felt like it could fall apart constantly. The U.S. was not nearly as committed as it may have seemed. Debates grew bitter. There was luck. And also, in that mess, there are takeaways that Susan and I both see. Lessons that apply directly to our biggest, slow-moving global environmental disasters today. We just don't necessarily agree on what those lessons are. The world agreed to stop using a pervasive chemical around the globe that also risked frying us all. CFCs. Huge victory.
The whole process worked together.
Go humanity. Let me tell you the rest of the story I see. The moments it almost didn't happen. Companies producing CFCs generally said publicly that they supported action. But the year before our guest Susan emerged from wind-torn Antarctica with strong evidence of the ozone hole and its causes, the powerful Chemical Manufacturers Association, which included DuPont, S.C. Johnson, and all the other majors, wrote its own report. It called the idea that CFCs hurt ozone a hypothesis. It had already funded counter-studies. It demanded more research, and until then, the report basically suggested
use with confidence.
The ground was being laid to deny any harm. In the meantime, DuPont had quietly stopped studying any possible replacements for CFCs, even though,
As a chemist, it wasn't rocket science.
And so only the discovery of the ozone hole and the panic that followed overrode growing complacency. Or go back earlier to the first hairspray bans in the US.
Get off the can.
Before chemical companies embraced,
The stick.
companies insisted they had no substitute, right up until the federal ban arrived. The next day, literally, an industry inventor announced a new non-CFC spray propellant. Flash now to the UN. The hole had been discovered. The treaty is being negotiated, when it all nearly unraveled. Europe had never banned CFC spray cans to begin with, so it had no precedent and less appetite for giving them up.
And so the European companies wanted to hang on.
Other countries that were importers of refrigerators and medical equipment that relied on cheap CFCs wondered what a ban would mean for them.
The developing countries began to realize that this could really screw them.
They worried the substitute for CFCs could be more expensive.
Just another way for the rich countries to impose costs on them.
Susan, watching the proceedings, saw the chance for agreement jeopardized. It wasn't until the final days of the conference that negotiators reached common ground. Developing countries would get more time before a cap went into effect. Producer nations would subsidize if there was higher cost. Europe came on board, and ultimately Susan says the deciding factor there was the market power of the U.S.
The American people made chlorofluorocarbons uneconomic for our industry because we gave up those spray cans.
You couldn't sell here anyway. Then, over in the White House, whether to agree to the treaty also quietly hung on a knife's edge. President Reagan had campaigned precisely against more regulation. His first head of the EPA had dismissed ozone depletion as a threat. His Secretary of the Interior said people should just wear more sunscreen. His cabinet was split as to what he should do. It's not clear what ultimately tilted Reagan to support the treaty, although he loved riding horses on his ranch, outdoors in the sunlight, and he just had his own bout with skin cancer right before the papers crossed his desk. The pessimist's version is, even with the science, even with public pressure, even with a visible hole in the sky, this almost failed. The pessimist's version is this was a training ground for later movements denying environmental threats. you could argue the loss on ozone galvanized later wins. In the years after the treaty, the House of Representatives held hearings about, quote, ozone myths. Influential voices grew louder mocking the science, such as radio commentator Rush Limbaugh.
The ozone hole. Oh no, we're destroying the ozone with cans of hairspray. There is no ozone hole now.
And disbelief has survived all the way to the highest levels of government today.
I said, wait a minute. So if I take hairspray and if I spray it in my apartment, which is all sealed, and you're telling me that affects the ozone layer? Yes. I say, no way, folks. No way. Okay? No way.
The pessimistic view would be that if the ozone hole were discovered today, we'd just argue about it until we burned. That even our prior gains to heal it shouldn't be taken for granted. And that if the goal is to apply the lessons of how we saved the ozone to our current, most pressing global environmental challenge, climate change, then what? We got lucky? Sorry, we're too broken now? I think there's some truth to that story. But there's another story that Susan sees. Within the mess. Within all the times that efforts to save the ozone nearly broke down, people always chose to surmount them. She says every time there was motivation to push through, and reasons why.
I believe there's 3 P's that dictate how we're going to do with dealing with an environmental issue. The first P is it personal? And this was clearly deeply personal.
Susan says from the early days of the first reports of a wafer-thin slice of ozone bleeding away in a century's time, people understood that it was going to affect their skin. President Reagan, skin cancer survivor, could understand how it was going to affect his skin. We needed to save our skins.
The second one is it perceptible?
Susan thinks the NASA images of a menacing blue wound on the world and the stories of a hole made it clear. Everyone understands a hole.
Well, that's pretty perceptible. You don't have to be a scientist to see it.
Finally,
the third P is, are solutions practical?
Consumers could abandon spray cans without abandoning deodorant. Policymakers could act, confident substitutes could be developed, and economies would survive. 3 Ps, Susan says. Personal, perceptible, and practical. They had power then, and she thinks they still do. So now, if you will, turn those 3 Ps onto our current biggest, most prominent environmental challenge, which is climate change. How do you think those apply?
Most people don't actually feel personally threatened.
Susan thinks climate communication failed at points where ozone communication succeeded. The dangers felt abstract, no hole to point at, no skin to save. The solutions have felt daunting, changing whole industries, putting people out of jobs.
I mean, people struggle with that.
I had figured Susan's personal journey would sour her on humanity's prospects. She'd join me in pessimism land. After all, 40 years ago, she measured a hole in the ozone in Antarctica, and it propelled a flurry of rapid global action. In the decades since, she's studied and advised countries on climate change. She's led the UN panel that publishes some of our most prestigious reports. She's suggested actions to policymakers. And the hole on this issue has only grown. The gap between human action and encroaching catastrophe yawning open. So, I thought she'd be jaded. She's not.
I think the prospects are actually quite good.
She feels like she's starting to see the same elements that drove the public outcry that led to chucking out spray cans, and eventually the kind of pressure that led to the larger industrial freezes and scalebacks.
It's becoming much more personal. People are beginning to really fear it.
There's no simple NASA image. There's lots more voices to tell you you can ignore it. But Susan says storms are here. The heat is here.
It's becoming much more perceptible. You don't necessarily have to understand the statistics if you know that, there's more 90-degree days every summer. I mean, I can see that happening. And the last P is really right now the stumbling block.
But she thinks that, too, is changing.
It's beginning to soak in that actually the solutions are practical.
All of which is giving her
confidence.
There are a few stories you can tell about the time the world came together to heal the ozone layer. You could tell a simple story about science leading to public action, to industry innovation, to global negotiation. And that's true. You could tell a nastier story about a series of lucky breaks and personal whims that barely overcame cynical opposition, all in a more navigable time. And that's true. Or you could tell a messy story combining both. One that summons everything you know about the world, full of human failure and self-interest, icy rooftops and chemical false starts, change that was difficult and imperfect. But facing a global problem, the world did stumble its way to an agreement. And the ozone is still not healed. I don't think we should take it for granted that it will be, but it's on pace. In a way, it's a more inspiring story than the simple one, because it feels more repeatable. In that story, we can see how, when it comes to saving ourselves from doom, we falteringly, but indeed,
Can.